Okay, and we are live. Let's go ahead and there it is. Excellent. Hi, everyone. My name is Derek Chowaniec. I am a security executive at GitHub. Today, we're going to be talking about security at the speed of GitHub. So historically, we've been known as a business that's been serving the developer and open source communities, but we also have some really outstanding capabilities around security that we're offering our users. The security solution that we're offering is called GitHub Advanced Security, and the goal is to help our customers drive greater risk reduction and scale without slowing down developers. Excellent. So as we start to go through this presentation, you notice that there is a chat window. So we'd love to hear some comments, some questions. Of course, if you do have a question, if you want to share anything, please raise your hand. And as we start to go through this presentation and demonstration, if you want to maybe have like a follow-up demonstration or a deeper dive, please let us know. You can certainly request one of those as well. So before we start getting into our capabilities, right, I really want to start with addressing why, right? Why has GitHub chosen to offer security capabilities in the first place? And it really starts with what you're seeing here. So one of the things that we did was we gathered a tremendous amount of data. In fact, we had an internal team analyze roughly 70 million lines of code for major open source projects over a 5-year period. And what we ended up seeing, quite simply, is more code equals more problems. So as the number of lines of code increased, what we started to see is the number of security threats introduced and commits mentioning vulnerabilities also increase. Which explains why flaws in applications are still consistently the number one attack vector for breaches. But what we get asked time and time again is how, or rather why. Why does this keep happening? Why are we living in a time when a new security incident is being reported literally every single day? In fact, if you take a look at a lot of the breach reports for some of these security incidents, you'll notice that an alarming number of these are as a result of application layer risk. And I like to ask that question why, because to be quite honest, not much about what we know about code security is new. So bear with me, right? What I mean by that is, we've known how to identify and remediate the most common secure coding flaws for over 2 decades. In fact, cross-site scripting was first coined in 1999 by engineers at Microsoft. So we've known about these sorts of issues now for, again, 2 decades. Yet, for example, cross-site scripting alone is still one of the most pervasive web vulnerabilities that we encounter. We've also had access to plenty of education. There's, countless, companies offering secure coding training, education. We've had an established set of secure coding best practices. In fact, the Open Web Application Security Project was founded in the early 2000s. So again, we've had plenty of this covered now for over 2 decades. And to be quite honest, we've also had access to highly sophisticated automated security testing tools, many different analysis techniques that are surfacing security information in first-party as well as third-party code. In fact, a lot of the commercially available solutions that you're probably familiar with have been around for, again, 2 decades or so. Many of which kind of were founded in the early 2000s as a way to kind of offer businesses an alternative to, or a rather faster and cheaper alternative to manual penetration testing. So, we've had all this information, we've had all the tools, and really kind of what we've come to this conclusion that developers are the key, right? So what we really need to be able to do is secure the whole developer workflow to help solve many of these challenges. And with that said, I think that we've all heard about shifting security left, but that's also not new either. In fact, the industry as a whole has been trying to kind of shift security left for at least a decade. I entered the security space around 2007. In fact, I've been preaching kind of my own shifting security left story again since 2007. So that's not new either. And I think at this point, it's almost kind of been beaten into us, for lack of a better way to say it. In fact, if you take a look at the majority of let's say the most well-known security companies out there, they all have kind of their own shifting security left story as well. So another question is that, if this also isn't new, then why are most businesses still struggling to shift security left, to catch these risks earlier in the software development lifecycle. Well, what we really need to do is really kind of change our definition of shifting security left. I think that the majority of us, when we hear shifting security left, I think in the back of our minds, or rather maybe some of the marketing material that gets shared, what they're really saying is, yes, scan early and scan often. But most of the time, the definition of shifting security left is taking some security tool, purpose-built for some security professional, and just sticking it in an IDE or everywhere that a developer does their work. But in reality, something else needs to happen. And by changing our definition, what I mean by that is, you see, a lot of the security tools, a lot of the security information, when it was developed, it was actually purpose-built for security professionals to address the software assurance use case. A lot of these security tools were never developed with developers in mind, and they certainly weren't developed with remediation in mind. And so with that said, GitHub as a business has come to this conclusion that, in order to really, truly make this shift happen, it requires a developer-first approach to security tooling. And that's precisely what we're doing with GitHub Advanced Security. So what we're offering with Advanced Security is a developer-first, community-driven approach to code security. And what you're seeing here is this is actually our product strategy, or at least two parts of it. We're trying to build security for developers to facilitate greater risk reduction and greater scale. And we're also taking this community-driven approach. And what I mean by that is, look, there's no one company on this planet that has access to infinite development resources or security resources. So in the case of application security, it truly takes a village. So with that said, just like some quick examples, we're offering some natively kind of built-in security testing solutions in our platform, but we don't expect to kind of do everything or cover every single analysis technique. There's a lot of businesses that are leveraging and finding value in many other security, commercially available security tools or open source solutions. So what we've also decided to do is build an entire security platform with many different integrations in a growing partner ecosystem via this great security platform and security marketplace. Great. So what is covered with GitHub Advanced Security? Or rather, what are we focusing on? We're focusing on the supply chain. That is our software composition analysis solution. So with GitHub Advanced Security, we are offering dependency reviews. We're also focusing on your code. So we have a code scanning static analysis solution built into our platform. We have a secret scanning solution baked in as well. And we also give our customers the ability to see what security coverage looks like across an entire business via our security overview. Excellent. So as we think about how we want to build or offer security capabilities to developers, there's three different themes that we're thinking about to successfully, again, secure the entire developer workflow. The first theme is develop developer-first tooling. Really what we're saying is that we want to be able to offer and develop security capabilities that are going to meet the security requirements of security organizations, but are built with developers and remediation in mind from the beginning, making sure that we're not modifying the developer's workflow, but we're actually be able to seamlessly fit inside of that workflow. Surface information that makes sense to developers in a way that makes sense to developers. The other theme is having all these security capabilities and information just offered native within the GitHub platform. One of the biggest kind of impediments, or one of the things that truly impacts developer productivity, is having to constantly context switch, right? In fact, the average enterprise class business manages roughly, I think it's around about 150 different tools. Developers waste a tremendous amount of time, going to one tool for quality results, another tool for security information, and kind of going back and forth, reading, reviewing results in yet another different place. But if we can have everything in one centralized platform, that will certainly allow developers to stay focused and stay focused more on remediating vulnerabilities or risks. And the last theme is automation that makes sense. When we think about automation within the context of like a security tool, we think about automating scanning, right? Or automating the the ability to export results from some security tool to some other place. And of course, every tool should be able to do those things, but we're thinking about automation a bit differently. When we say automation that makes sense, we're thinking about automation that facilitates greater risk reduction and automation that facilitates greater scale. And there's a great example of this. So what you're seeing here is an example of that. It's an advanced security enforcer action. And quite simply, what this action does, it extends some of the capabilities of GitHub Advanced Security. And anytime a new repository is created, one of the things it automatically does, it enables all of our security capabilities automatically. So using an action like this can help businesses auto-scale security testing and coverage with a minimal team of full-time resources. So of course, we're out, or rather with this goal to build security in the entire developer lifecycle, have it natively available. But we actually want to show you what this looks like in action. So it's demo time. So at this point, I'm going to hand it over to Colin.
Great. Thank you, Derek. Let me see if I can share my screen quickly. Share this window. All right. It looks like it's sharing. All right, so thanks everyone for joining this session. My name is Colin Dembovsky. I'm a solution engineer here at GitHub. Joined GitHub probably about 8 months ago, but have been in the DevOps industry. I did DevOps consulting for about 10 or 12 years, and I have a development background. And just before I get into my demo, I wanted to talk a little bit about my experience in security from a developer perspective. And this has been a really amazing journey. Just as I get together with some of the folks like Derek, who have the security background, and seeing the focus on developers has been really amazing to see. And so my first job, I did C and C+ development, and we used to put print lines all over the place to debug, and so I would have to put entering method, and then I would have counter is whatever value and total is whatever value. And then I'd run the application and I'd look on the console and I'd see what was happening through the program, right? And I remember the first time I opened up Visual Studio in my second job, it was a Microsoft shop, and I opened up Visual Studio and I realized I could set a breakpoint. And that productivity, thinking back now, I took it for granted as a developer back then, but that jump in productivity from having to write print lines to setting a breakpoint was really revolutionary, made me a much more efficient developer. And then I remember us spending Friday afternoons nursing the build. So we'd have a build, and it was pretty complex. And on Friday afternoons, we'd all watch the build, and we'd be barbecuing and have some meat on the grill, and we'd watch that build. And when I think back to that, we had probably 7 or 8 developers spend 4 hours a week nursing the build. And so when you see build automation come in, and the productivity that we gain from build automation, again, it was something that we kind of take for granted in the industry today, but really is kind of revolutionary. And then the kind of black sheep in that whole DevSecOps pipeline from a developer perspective has always been security. And security has always been one of those things that's a necessary evil as far as developers are concerned. And if I think back on my career as a developer, I think part of that is because there was never this focus on making security a developer-first concern. And so I've been trying to think about why I find GitHub Advanced Security so compelling. And as I've thought about that evolution of going from just a plain text editor to an IDE to improve my productivity, and then going from manual builds to automated builds, again, improving my efficiency. Now we're applying that same quantum leap into the security realm. And this is what really excites me about GitHub Advanced Security. So I want to show that here. And I have a GitHub repo up here. There's some Java code in this GitHub repo. This is not really a coding demo, but I really wanted to show from the perspective of a developer how our security tooling fits seamlessly into that developer workflow. So I don't feel like it's interrupting my flow. I feel like I can be a much more efficient developer and still produce secure code. So this application happens to be a bit of Java code that we deploy into Azure. Again, the details are not important here, but it's a book catalog. And we have an item on our backlog to implement a search feature. So I'm going to jump over to a code space. And if you've been seeing some of the keynotes, my colleague Kevin Orwell showed code spaces in a little bit more detail, but I have some code that I've changed here, right? So this is showing a diff that's in my workspace now, and I've added my 5 or 10 lines of code here. So I've made some change here. I'm just going to commit that change. So implement book search, and I'll commit that. And then once it's committed, I'm going to publish that branch to my repository. All right, let's just, I want to do this quickly. Let me do this from the command console. Push, and I'll have to set the upstream. 1 second. And what am I getting there? Failed with some refs. Okay, let me do a pull quickly. All right, let me see if I can get this going again. Oh no. All right, let me open up a new code space. I can implement this pretty quickly. I thought I had this all set up, but for some reason my push didn't work. So bear with me 1 second. While that fresh code space is spinning up, what I wanted to show, I'll go over to the security tab here, and I want to show this security tab is what comes up when we have GitHub Advanced Security enabled on a repository. And let me actually go to settings and show that, because this is something I love hearing Derek talk about instant on and how significant instant on capability is. And if I go to code security and analysis, I'll see some of the toggles that we have for GitHub Advanced Security features within this repository. And this is very significant. Again, even if you have one of our competitor tools, you have a problem rolling these tools out at scale. Let's say you have some kind of secret scanning tool. Well, where do you put that secret scanning tool? If you put it with the developers, they may forget to run it. If you put it in your CI/CD pipelines, you have to change your CI/CD pipelines to do the security scan or the secret scanning. And so this becomes a real problem for enterprises that are trying to roll out security at scale. And so being able to turn on secret scanning with just a button click, being able to turn on our dependency scanning, which is going to scan for all the dependencies here. This is a Maven project, and we're pulling in a whole bunch of Java libraries, and being able to have dependency checking where we're actually looking at the dependencies and automatically notifying when there is a vulnerability. To be able to turn that on with a button click is a game changer. And because it's native to our platform, we're the only platform that can do this, right? There's no other security tooling that can do this, because we're the only security tool that's really native to the platform that developers are in every day. So once I've turned that on, let me go to the security tab, and I'll click on Dependabot Alert. So this is our dependency scan, and you'll see that there is an alert here. And if I open that up, this is looking in my POM XML file, right? And we support most major package language systems like NPM with package JSON, with CSproj for NuGet and so on, right? This happens to be a POM XML for Maven. And Dependabot has found that we're pulling in a version of JUnit, and our version is between 4.7 and 4.13. And there's a vulnerability in the CVE databases. And here is the information about that vulnerability. And so we can see what the impact is. We can see what the patches are. We can see any workarounds. There's a whole lot of information here. Again, not just can we make a developer aware of an issue, but can we help a developer fix an issue and understand what is going on with that issue so that they become better developers, more secure developers. And again, because this is right in the context of my repository, it feels very natural to me as a developer. So I can see the patched version is 4.13.1. And you'll see that there's actually a pull request. Not only do we have an alert that there's a vulnerability, but Dependabot has created a pull request automatically to bump this from 4.13 to 4.13.1. If I go and look at the files changed here, what did Dependabot change? It updated the POM XML file to bump from 4.13 to 4.13.1. Now, if I couple this with actions where I'm compiling my code, running my unit tests, by the time I get to review this as a developer, I already know, or I already have a really good feel for, is this going to break anything in my existing code? And so I don't have to do any of the heavy lifting of finding what the patched version is, going and doing the patch, going and running all my unit tests. All of that is done by the time I get to my repository. And so this shows just how much more effective we can make mitigating vulnerable dependencies. All right, so let's go over to the code space, see if that's running. try this again. I'm going to implement that code space. I've got a cheat sheet for that, or that code change. So let me see if I can get this to work. And it's the book search. That's going to create a new branch for me. And I actually think I know what the problem is. The problem is I had an old branch here. So I'm going to just delete the old branch that I had. Again, give me 1 second. All right, delete that branch. All right, so I should be able to push that change. So again, I have some code change here that let me increase the font size a little bit. So I have some code that I've changed. Again, I'm implementing that search feature, and I've done whatever code changes I think I need to do to change that. All right, so let us commit this, implement book search. This time, I'm pretty sure I will be able to push this. So let me publish that branch. Yeah, all right. So I forgot to sacrifice a chicken to the demo gods this morning, but everything's turned out well. And so that's pushed that branch. And what I didn't do there, which I should have, is created a pull request straight from my code space. But I can do that over here. I'm going to hit compare and pull requests. And there's, again, implement book search, and I'm going to create that pull request. So again, this is just my daily development workflow. I'm changing code. I'm implementing code from the backlog, or implementing tasks from the backlog. And now, because I've created that pull request, we have automation that has kicked off by that event. We have an event that says when someone does a pull request into main, go and execute these automated tasks, right? This is using actions, which is our CI/CD system. And you'll see one of them is this code scanning action, all right? So I'm going to click on details so you can see it in real time. And this is a YAML file that's inside of the repository. It's a very simple YAML file. And there's really a couple of things that we do. We initialize the code scanning, and that's going to create an empty database for us. And it's going to hook into our build process. So in this case, we know we're doing a Maven build, so we're hooking into the Java compiler. And so we initialize CodeQL with the language that we are targeting, right? Because CodeQL is language aware, and that's going to create this empty database, create the hooks into the compilation process, and then we're doing a custom build step. Now we do have an auto build that's going to do a best effort build, but if you have custom build steps, you would just put them in here, and these are whatever build steps you need to execute in order to build your application. And once we've done that, that populates the database. So while we're building, this database that I spoke about is being populated with a graph of our code. And again, CodeQL understands how our code works. It has semantic knowledge. It has data flow knowledge. So it knows how data flows through our application. And so once we've completed our compilation, we can then execute a suite of queries. And this is where CodeQL comes from. CodeQL stands for Code Query Language. It's kind of like T-SQL. And the great thing about this is that you can create your own custom CodeQL queries if you need to. But coming back to what Derek said about a community approach for application security, we're leveraging the community. And so the suite of queries that are being executed here come from our open source repo, which is the CodeQL repo. And we have a pack of Java queries, which are created by some of them by us, some of them by the community. Our security professionals curate that repository, but that list of queries is updating all the time, right? As the community finds new vulnerabilities, as the community creates more queries, as our team creates more queries, that suite is just growing over time. And so we're executing all of these queries, and I'm scrolling down and down and down. All of these queries are being executed. And you can see there's a summary at the end here. We've analyzed 441 lines of source code. So again, a little bit of a sanity check there to make sure that we're scanning what we think we're scanning. And that's just to show you a little bit what happens under the hood. But what does this mean for me as the developer, right? So I've had my pull request, some action has queued off. Now, if I go back to that pull request, I can see there's this little red X next to my pull request. That's probably a bad sign. So I'm going to click on that implement book search, and I'm going to go and look at this pull request. And I'm going to take off my developer hat and put on my code reviewer hat. And I can see the code coverage here because our action posts back the code coverage results here. But what I'm really interested in is I have a list of checks here, and most of them are green. except for this code scanning one, which is where that red X comes from. So there's some kind of check that's failing here. So I can click on details, and that'll take me back to that action that I just showed you. So I can see in line what action failed, or which step in that workflow failed. But I can also see that if I go to files changed, I'm going to see in line in my pull request, these are the lines of code that I changed and I pushed on this branch. And I can see here that I have unchanged files with check annotation. So there's some kind of annotation. And here is where we see this red X. So this red X is detecting that on this line of code, on line 120 in book database implementation.java, we have a code scanning alert, and it says query built from user controlled sources. Right? So I'm going to click on show paths, and this is a Java servlet. So when that book application comes up on the browser, and I fill in the title that I'm searching for, and I click the submit button, this is the entry point in my code that is then going to parse the HTTP request and extract this parameter called title from the post to my servlet. And then once we've parsed that, we're passing it into the search books method, and then that's defined in bookservice.java. So here's that search books method, which is then going to call our books database implementation, get books by title. And here's that file. And again, there's the method where it's coming in. And here's finally where it ends in the sink. So CodeQL has shown us where the vulnerability is, as well as shown us how the data flow through our code works, so we can understand where are the sources and where are the sinks and what's the entire data flow through here. Now, in this case, there's only a single path to this, but you could conceive of some backend methods where there's a vulnerability deep down in your stack somewhere that has multiple entry points. And so again, CodeQL will surface all of those different paths so we can understand how that code has flowed to the point where there's a vulnerability. All right, so let's look a little bit more at what this vulnerability actually is. Right, so I'm going to click on show more details here, and that's going to take me to this to the alert. Right, so we're back in the security tab, and again, I could click show paths to see all the paths here. But we see this is a Java SQL injection rule, and here's the short description. And again, I can click show more, and I get very detailed information about what this vulnerability is, what the recommendation is. I get to see some examples. Here's some bad code. Here's how would make that good code. Here's another example, some more explanations to it, some more good code, bad code, some references down here showing CVE links. And so again, this is not just about can we find a vulnerability, but can we focus the developer on this is a real vulnerability. So CodeQL has an incredibly low false positive rate. So we're not inundated with noise that we're just going to dismiss, right? We're actually getting alerts that are meaningful. And then once we've opened up that alert, we're providing the help that a developer needs to actually mitigate this. So we're reducing that mean time to remediate once we've actually discovered those vulnerabilities. And so again, the developer can go here, and the reviewer could fail this review. The developer could open up the same set of files and security alerts, and they could see what this issue is, and they could go ahead and fix. Now, I want to show one more thing. So this is coming from our native code scanning CodeQL tool, which is our static analysis scanning tool, our SAS tool. But the way we operate our SAS tool under the hood is we use a Serif format. So Serif is a JSON format that's standard in the security industry around. It stands for static analysis results interchange format. So it's a JSON file that lets you encapsulate scanning results in a standardized way. And if I clicked on tool here, you'll see that I do have CodeQL here. It's showing 0 because it's actually on a PR, not in not in the main branch. So it's filtered that out. But you can see that I have Gripe and Anchor and Trivy. So this is a good example where we're allowing the community to use other tools that produce Serif formats like Anchor and Trivy, which are container scanning solutions. And because we're allowing them to upload their Serif files, we're able to integrate with other security tooling. And again, Derek spoke about us not just giving another tool to developers, but really creating a platform that can be this single pane of glass really for security. And it's right, again, built into the very platform that developers are busy with every day, right? So I can see container image scanning results here, and I'll click on this one. This says high vulnerability for log4j. You may have remembered log4j came out in December, and so this is a layer inside of this container image that has a log4j vulnerability. And again, I get the same kind of experience with the show more, and this is going to depend on how verbose the tool is. But I wanted to show that we can integrate other tools, right? So I can.
Hey, Colin, real quick, when we also say, other tools, it's not just like, commercially available solutions that you might have been using, for a while.
Right.
It's really anything that can export results in Serif format. And so, I've met a lot of security professionals that are huge fans of open source tools and solutions as well. Those can be integrated. In fact, we already have integrations for many of those in the marketplace already. So a lot of those integrations are just simply instant on, right? And it doesn't just have to be things like another static analysis tool or something else for checking your dependencies. You could have a container scanning solution that you're in love with, or let's say you're using a tool like Now Secure for mobile security testing, right? All of those can simply be added so that, again, your developers are seeing everything in one place, but they're seeing in a way that makes sense.
Right. Yeah, exactly. That's a great point. Thanks for calling that out, Derek. I wanted to show here on the settings for this repository that I can go to this check failure, and here I can actually set a policy for preventing a pull request from being merged in, or preventing the check from succeeding if there are high or higher critical or higher severity errors in my code scanning. And so this shows how we can then use the code scanning results in actually driving the workflow that we have in a very easy way. We don't have to write a whole bunch of code to go and analyze, do we have failures here before we merge in? We've built that into the platform, so it's very easy to integrate that in. All right, so we've covered dependency scanning with Dependabot. So that's scanning all my dependencies that I'm pulling in. I've just showed you very quickly what it looks like to scan the code that you yourself are writing or your teams are writing. The third functional area that we have in GitHub Advanced Security is secret scanning, right? So you'll see that here. We have a secret scanning section where we can define custom patterns. Now, we have partnered with major SaaS providers like AWS and GCP and Azure, and really a whole list of partners that we've worked with where they've said, this is the pattern for our tokens that we issue. And so we've integrated from our partners these patterns into our scanning, into our secret scanning tool. You can also, though, define custom patterns. So let's say that you were issuing tokens for your APIs and you had some kind of hash format that you were using. You could put this in here to make sure that your developers are not checking any secrets in that match that token format. Now, you'll also see this push protection here. And again, Kevin Allwell did a great demo of this in the keynote yesterday. But what this is, the secret scanning is post commit. So I've already done my commits, and then our secret scanning is going to go and check the repository to see, are there any secrets here? Or when we turn it on, we're going to do a complete scan of history to see, are there any secrets existing, right? And that's fine, but we want to prevent, once we've turned it on, we want to actually prevent new secrets from getting into the repository at all. And so this push protection, what this does is it executes the same secret scanning logic on the push, and will actually fail the push if it detects a secret, so that the secret doesn't even get into the repository in the first place. And so that's something you can enable or disable according to your policies. But really love this feature that this is getting to the point where the platform is actually even preventing a commit with a secret from even getting into the repository in the first place. And then I wanted to show, I'm going to go up to the organization level. So I've been working in the repository, and that's really the hub of the security tooling is really at the repository level, which works fine for me as a developer. It works fine for a Scrum team. But what if you're in the compliance and security or InfoSec team and you're managing hundreds of developers or thousands of developers? How do you see what your risk posture is at scale? And this is where, if I go to the security tab at the organization level, I get the security overview where I can see an aggregation over all the repositories that are in this particular organization. I can start seeing we've got just over 1,300 repos, and I can see a breakdown of high, medium, low, and clear for risk. I can see which repos have those features enabled or not enabled. And if I show more, I get a little bit more detail on code scanning, Dependabot, and secret scanning alerts. And again, which repos or how many of our repos have it enabled or don't have it enabled. And then down here, I get to actually see that roll up per repository. And so again, as a InfoSec professional working in this organization, I have this single place where I can go and manage risk at scale across the enterprise. I think that's about it for the demo, Derek. I can hand back to you. There may be some questions. We're going to leave some time for Q&A. But anything you wanted to add to the demo there? I did that really, really fast. I'd love to dig into these in more detail. We just don't have the time. But hopefully I've given a good flavor for what this looks like from the developer perspective and from that InfoSec professional perspective in our platform and what those tools actually look like on the ground.
Yeah, absolutely. I think one of the things that I think some of the members of the audience might be interested in are like, how is this enabled across basically like an entire organization, right? And you mentioned that these features can be enabled, but like how exactly can then be enabled, right? Because I think one of the things, one of many things that like someone in a security leadership position is interested in is like, what does my coverage look like, right? Like I've spoken to so many customers just like throughout my career where they've run into these challenges being able to scale security testing across every asset that they need to manage for, across every single developer, right? And there's been some challenges around achieving like the sort of scale that they need. Either they had only a few people that were responsible for integrating and automating tooling, so they couldn't do it because they didn't have enough people or internal resources, or ended up just being cost prohibitive or just too complicated, right? So if you can kind of touch on how with the GitHub Advanced Security, we're able to help those customers kind of achieve the level of scale that they want to cover every repository that they manage.
Yeah, so I'm going to answer that question at two levels. So at the tactical level, I've gone up again to my organization level to the code and security analysis section of my settings. So this is at my organization level. And you can see I can turn on dependency graph, Dependabot alerts, GitHub Advanced Security, secret scanning. This is that, and I'm going to borrow your phrase because I love this so much, it's instant on. And again, I alluded to this a little bit. So let's say that you want secret scanning across your organization. Again, this is almost impossible to do in any other platform if it's a third-party tool or if it's some external tool that you're trying to bolt on. Here, we just check box, secret scanning. We can automatically enable it for new public and advanced security repositories, and it's on, right? We don't have to go and educate teams and go team by team. A little bit more work to do, arguably, for CodeQL, where there's a compiled language involved, mostly around because it hooks into builds, right? So those builds tend to be very custom, very application or team specific. But as far as Dependabot and dependency scanning and secret scanning, these are instant on. And so again, this is very significant when you're talking about security at scale across large organizations. So that's kind of the tactical level. I think at the sort of higher level, the strategic or business value level, again, what I've showed you here is the administrators and the InfoSec professionals. They come and they enable these settings. They can enable policies. They can ensure that these policies are enabled at the repository level. And then they're freed up, like just like I, as a developer, I'm freed up to do feature work when I'm not doing my builds manually. In the same way, GitHub Advanced Security, the platform and the features that we have, frees up your security team instead of spending their time nursing the tools, right? Nursing some server somewhere that's going to perform all your scans and categorizing your applications for which ones are we going to scan or not scan because it's so expensive to scan. And instead of doing all of that sort of operational, really non-value add, we're now freeing up your security professionals and your security teams to work with your developers to bring that security culture into your developers. And that's real value add. That's real value add for the business, helping the security professionals do what really matters to the business, right? Instead of nursing all these different tools and trying to extract large PDF dumps so that they can get it to the developers, and the developers have already moved on, so they're not going to fix it, and having all those kind of, I'll throw it over the wall to security and security is just going to block me. And we're facilitating a cultural change and a cultural shift where we're helping security professionals help developers to be more secure developers in a very natural, very intuitive way in their daily workflows, rather than having to have this army of security professionals just keep the tools running and kind of keep the lights on.
That's great. Colin, one other question I have, and I think, I heard was, talk to us about being able to prevent, right, net new risks from being introduced, right? I'm not sure if you actually touched on some capabilities that we're actually seeing here, but like I see push protection, right?
Yep.
If you can kind of touch on that, and also kind of what we're doing to proactively prevent risks from being introduced from purely from a dependent bot or software composition analysis perspective as well.
Yeah. So I'll answer the secret scanning one first. I did touch on that a little bit, how we have push protection, which runs our secret detection, our secret scanning logic to detect secrets before the push actually succeeds, right? So if you go to your console and you type git push and we detect a secret, we'll fail the push, just like you saw my failure earlier on because I was trying to push to a branch that was out of date. Same kind of experience. It's going to fail that push, and the text that comes back in the console is going to tell me, we've detected a secret. Here's a link to the secret. Again, Kevin Orwell showed this in the keynote yesterday. So if you want to see a little bit more detail of how that one works, I'd encourage you to go and watch that keynote and look out for Kevin Orwell's section where he covers push protection in detail. For Dependabot, Dependabot is actually enabled. You can enable that on your repositories to do the vulnerability alerting. What we do provide as part of the GitHub Advanced Security license is we have something called dependency review, and that's when you can actually then not just get notified of those dependencies being vulnerable, but you can actually put in a policy that prevents those pull requests that are introducing vulnerabilities as part of that push, as part of that commit. If I'm changing a library in my commit and I change it to a vulnerable version, I can actually block that from succeeding until the developer has gone back and updated that. So again, that's shifting it to the point where most developers, they don't know whether they're bringing in a vulnerable package or not. But now at the pull request experience, they're getting this integration in where not only are they getting notified when new vulnerabilities for their existing libraries are found, but when they're pushing and adding a new library or updating a library as part of that push, we want to make sure that we're not introducing libraries that have vulnerabilities. And so you can enable that to block those pull requests from succeeding if we detect that there's a vulnerability introduced as part of that.
Excellent. Colin, another thing that gets brought up is about how we're not trying to hold this data hostage, right? I mean, so we're surfacing some really important information here for developers, those members of the security organization. Maybe you can talk a little bit about how we're able to kind of export some of this data right to other places, right? Whether it's another security tool, whether it's like a reporting or dashboarding sort of solution, or even like a GRC tool. Can you maybe talk a little bit about how we're able to kind of take all this valuable information and just use it in other ways?
Yeah, great question. So in the security tab, I showed you where when we have a dependency alert, we create this alert here in the security tab for that repository. Same for code scanning and secret scanning. And again, because we're building onto this GitHub platform, which is very rich in terms of notifications and webhooks, and we have this very rich eventing system. These are just events that come out in our audit log. So you can monitor the audit log, and as new vulnerabilities are found, they will come up in the audit log. So if you're streaming our audit logs to Splunk, for example, Splunk has a GitHub application in the Splunk marketplace that will put some dashboards up, and there are some GitHub Advanced Security dashboards that look specifically at things like mean time to remediate, because we know when the alert was opened, and when that is remediated, we know when it was closed or remediated. And so we can actually start helping visualize what is our mean time to remediate across a subset of teams or across our organization. So we have that in our audit log. we also fire off a webhook for each alert that is created. And so again, you could hook up a function or a Lambda or anything that can respond to a webhook. And as these alerts are popped up into the security tab through the scanning tool, through Dependabot, through secret scanning, that will fire off that webhook, and you can put whatever other automation you want around that just by triggering off of that webhook. And so really, again, we're providing these constructs that we've given you some good implementations of this, like the security tab, but we realize that we're not going to be able to build every kind of integration that you want. And so we've made it very API driven, very webhook driven, very event driven. And so you can put in additional integrations off of the platform that we're building. And again, I think that's so huge, is that it's built into this platform, and we know we have over 70 million users globally. So if there's an integration possible, chances are it's already been built. So we're going to see more and more from the community in this space.
Excellent. Another question that gets brought up pretty frequently is, obviously we're part of greater Microsoft. Microsoft made this tremendous investment in GitHub, and also just, GitHub is a security business as well. We just kind of shared some information about being able to kind of feed data into kind of external other sorts of tools. Just based on your experience, coming from Microsoft or having experience with Microsoft, what are some of the integration points that you hear or have heard that our customers want to see?
Yeah, I think Security Center in Azure is a very natural place where Security Center is really the hub of security. It's your single pane of glass for security for your entire Azure estate. And so we're working on integrating into that. So again, as these alerts come up, you want them to be in GitHub for the developers, where the developers are working, but you may want to consolidate those and at least have visibility to them in Security Center in Azure. And so that will bring this the application security, even though it's very focused on the developer here, will surface some of those metrics and some of the insights into Security Center. So the Security Center for Azure at least becomes this single pane of glass across all of your Azure estate, plus your AppSec as well. And again, other cloud providers could very easily integrate into their security center equivalents, right? Because again, we have the APIs, the webhooks, we have all of the extensibility points. So any cloud provider could do that as well. Any external security tool where you're wanting to monitor or manage risk in some kind of external tool, you could very easily integrate our platform into those external tools.
Great. Another question that was brought up was, how are some of these capabilities accessed, right? Because, immediately you think, hey, is this only available like in GitHub Enterprise Cloud, or is it available in other places? And obviously I bring that up because, we're committed to providing, developers with the best possible experience, the best possible capabilities, but is it just available there, or can you get it in other sorts of tools that we offer or solutions?
Right. Yeah, great question. So for forever, we've only had one license really, and that's the GitHub Enterprise license, right? Other than sort of the team SKU or the free repos. But when you get into the enterprise space, we would just sell a license, a GitHub Enterprise license. Now that enterprise license is assigned to a user, and that allows you to access either GitHub Enterprise Cloud, which is our SaaS solution, as well as GitHub Enterprise Server. So if you're running our server virtual appliance inside of your data center, then that license covers you for either or both platforms. And you can actually hook up a server and a cloud instance through GitHub Connect. So that's, for a long time, that's really been the only SKU we've had. GitHub Advanced Security is an additional SKU that you would purchase over and above the GitHub Enterprise license. But again, it is available for GitHub Enterprise Cloud as well as GitHub Enterprise Server. You have to be on one of the more recent versions of GitHub Enterprise Server, so you will have to get up to date. I think we started on 3.0 or 3.1. I don't one of the three series for GitHub Enterprise Server where we supported Dependabot and CodeQL and Actions. These are all things that are supported now in GitHub Enterprise Server. But to enable secret scanning, dependency review, and CodeQL, you will need additional GitHub Advanced Security licenses. We enterprise.
Colin, another question that gets brought up, especially from, I think, people that have historically kind of used like traditional kind of security tooling, how can we use or leverage some of these capabilities in kind of like a blocking mode where your developers aren't going to hate you?
Yeah, again, I think that integration into that workflow, into the pull request is really that first step. I wrote a blog post about code quality versus code security, and again, having been a developer and used some code quality tools, you often say, well, you know what, I know I have some code quality issues, but I'm willing to deploy even though I have that. It's sort of a risk that I'm willing to take, and I think it's the same process here. I think it's a little bit more critical that you sort out your secure code. You want to secure code is quality code. I'll put it that way. As that contrast, but again, it's around risk mitigation. And so the first step is really having visibility. Do we have vulnerabilities? So most teams that are deploying code, the first thing they don't know is they don't know what vulnerabilities they have. And so using our tooling, we can at least make you aware so that you know what is the risk for this application. And then from there, the teams can then make those cultural shifts to then bring stricter and stricter controls in. Again, because it's integrated in the platform, it's not something developers are going to hate because it's really built into their workflow. It's not context switching. It's not, oh, well, I did the scan 2 weeks ago and then it took 2 weeks to get the scan results. And now I've already done 2 weeks of development. It's really baked into that developer flow right in the moment. And so I think this is going to make it a lot less disjointed for developers. And that's going to be good for security of our applications in general. All right, I think.
How about some of the? Yeah, I was just going to say
questions in the Q&A.
Yeah, we're going to switch over to Q&A in just a second. One last one that was brought up as well is, how else is some of this information kind of presented across other parts of GitHub, right? So obviously there's that security kind of section there, that tab, but we talk about how security information is presented in a way that makes sense to developers. Like what else can they do, or how else can they interact with this information? Maybe within the context of things like issues.
Yep. All right. So again, if I click on security here and let's go to one of the code scanning alerts. All right, so we may open up one of these code scanning alerts. I can, if I have permissions to, or if I have a security administrator role, which is actually a separate role that we allow you to define in your organizations, I can have this dismiss reason. And again, if I dismiss this as a false positive, it comes in the audit log and there's webhooks and so on. So we can build process around how these alerts are dismissed. But this might require a little bit more work than just, I'm going to dismiss this or I'm going to fix it today. So we can create an issue, and that's going to create an issue. I'll hit submit new issue. And that's going to create this tracking issue, which we can then add to our project boards and our project vNext, again, which was demoed very, very, very well by Kevin Orwell in the keynote. And so this can now be put onto a board somewhere so we can track. And again, there's this link through from this issue to the actual vulnerability alert itself. And so this is the point where we would encourage, or where we're encouraging teams to use all of the collaboration tools and all of the discussion capabilities here to work through these issues. And so again, it's not just a security professional somewhere who's got this alert, but we're allowing the team to iterate over, how do we fix this? What do we need to change? Is this a good approach? Is this a good approach? And we're hooking into that existing workflow and the existing core of collaboration tools that exist on GitHub and the GitHub.
Excellent. So at this point, we're going to take some time for some Q&A. Let's see here. I don't know how to pull back control, but maybe we can kind of go through some of the questions that were asked. Let's see here.
I see a couple of questions. So I've got a question here for, how does Dependabot work with Ant builds without files like pom.xml? So what I showed you, a Maven build, which has a pom.xml file for Dependabot Today, we only support a handful of package management tools like package.json for NPM, Maven with a POM XML file. We are about to put into public beta something we call dependency API, and this will allow tools, any tools, a tool like Gradle, which is sort of dynamic. It doesn't have just a single manifest file. It's very difficult to just look at the Gradle files and figure out what the dependencies are. You actually have to do a build through Gradle, and so that the dependency graph is generated dynamically. But the feature we're bringing out allows any tool to create that dependency graph for whatever package management system you have. So if you have Ant and you're pulling in dependencies that way, we would be looking at the community or at the third party like Ant or whoever's maintaining those tools to generate that dependency graph, and then we'll do the comparison against the vulnerability database. So today we support just really package manifest files for the Dependabot, but we're working on making that more dynamic for transient dependencies and for situations like Gradle.
Excellent. There's a question here. It says, well, they're asking about a session on creating secrets. I'm assuming this is like custom secrets. Did you cover how we're able to allow users to create custom secrets that we can?
I did very briefly, so I'll go back over to code security and analysis on this repository. And over here, when you enable secret scanning, this enables all of the secret scanning patterns that we have from our partners. So AWS, Google, Hashi, MailChimp, all of these kind of SaaS tools that create tokens. But I can also create custom patterns. So if I hit new pattern here, it's going to ask me what's a name for the pattern, a regex, and then I can actually test it with some test strings. And you'll see the save and dry run, which is actually a pretty big one because you don't want to put something in that's going to sort of falsely identify thousands and thousands of secrets. And so you can test those custom patterns in a dry run before you actually publish them and distribute them. So that can be done at the repository level, and it can also be done at the organization level.
There's another question here. It says, what if you block a vulnerable, so this is a Dependabot question, but what if you block a vulnerable version, but there is, hold on, where the heck did that go? But there's no patch for it yet.
Yeah, so in that case, we will create the vulnerability alert so that you're aware that there is a vulnerability. In that case, Dependabot can't create the PR, right? Because there is no patched version published. And so you still get the alert. You may not get the pull request if there's no published patched version.
On serif format, let's see, let's go through some other questions here. Ant builds. I think we talked about how to enable it. Did we talk about how to enable some of these features at an organizational level? I think we already did that, right?
Yep. Right.
Let's see here. Talked about SKUs that support advanced security. Do we talk? Do we? I know we kind of talked about some of the roles, but do we actually kind of see some of that information in a bit more detail?
Yes. Let me see if I can find that setting. I believe I'll have to find exactly where that is. I think it's on the teams. No, that's team discussions. Where is that? So there is. Let's just see member privileges. Let's see if I can remember where this is. On the team settings, where you create teams, which I'm not finding now, there is a section right at the bottom of the teams section where you can add users to the security administrator team, and that by being put into that security administration team, you get read access to the repositories that have GitHub Advanced Security enabled. You can go to the security tab and you could interact with the security alerts, so you could dismiss them or create issues from them and so on. But it really just gives you read-only access to those repositories. Of course, if one of your security admins is granted write permissions through our sort of normal roles, then they will have write permission. But security admin was a role we specifically created for enterprises where they said, well, we have these security professionals that are going to manage the alerts, but we don't want them to have write access. And so that's really the idea of that.
Colin, you've got about 3 seconds. Want to say thank you for joining.
Thank you, Derek.
Thanks, everybody. Have such a great day.